here. No, she's not. Okay. So Unit 4 is just about curve sketching. So in advanced functions, we would use synthetic division and the sign chart to help us figure out where our graph is increasing, decreasing, where our zeros are, what are turning points. What that did when we factored out those polynomial expressions to graph our curve in advanced functions is it just told us our x-intercepts. It didn't tell us where our graph was going to peak. We would have to find that manually by taking the roots and dividing them, adding them together and dividing by 2, and then finding the x value. However, with curve sketching and derivatives, what we'll be able to do is when we find the derivative, we're finding the slope of the tangent to be 0, which means there's either going to be a max or a min. Once we find our factors of our derivative, what do you think those are going to help us graph on our graph? The turning points, right? So it's going to help us find our maxes and mins, okay? So those roots in our derivative are when the slope of the tangent is 0, which means that that root or at that specific x value is where our max or min is going to be. And we could just simply plot that or sub in that x value into our original expression, and it will tell us where our max or min is going to be based off that value that we found. So we're going to be talking about intervals of increase and decrease. So as you guys know, intervals of increase is when the graph seems to be going up, and intervals of decrease is when the graph seems to be going down or has a negative slope. So one of the most useful things to know about functions is where its graph rises and where it falls. Remember, always read the graph from left to right. It's like reading a book from left to right. Do any of you come from a culture where you read from right to left? I know some of you may come from a culture that reads from right to left. Okay, how was it harder learning to read right? Was it weirder reading right to left or left to right? Okay, so some of you have some weird experiences. I mean, harder reading from left to right. Okay, so with graphs again, we read it from left to right. So the graph F shown in the figure below falls from A to B. So it's decreasing between my x value 1 and 3. So the slope of my tangent here is going to be negative. It is increasing from the interval 3 to 6. So again, the slope of my tangent is going to be increasing. And it is decreasing from 6 to 8. So from 6 to 8, it is going to be decreasing. Now, if you were to have a polynomial expression for this graph, there would be no zeros because we do not have any part of the graph touching the x values. However, if we were to take our derivative and factor our derivative, it would give us roots of 3, 6, and that's about it, because those are when the turning points happen, and possibly 1 and 8, because those are our max and mins as well. So again, slope of the tangent at the peaks and at the minimums and maximums are always going to be 0. So a function is said to be increasing on an interval if f of x1 is less than f of x2. For any x1 less than x2 in the interval, a function is said to be decreasing on an interval if f of x1 is greater than f of x2. For any x1 less than x2 in the interval. So how do we test intervals of increase and decrease? We find our derivative. So notice that the slope of the tangent lines on the intervals of increase and decrease. So f prime of x is greater than 0 for all x in an interval, then f is increasing on the interval. If f prime of x is less than 0 for all x in an interval, then f is decreasing on the interval. So in summary, for continuous and differentiable functions, the y values are increasing for all x when the derivative of f of x is bigger than 0. So that means I have so the slope of my tangent is positive. And they're decreasing when the slope of my tangent gives me a negative result. Okay? So again, we're just learning about the basics. This should be a pretty easy unit. I'll try my best and not give you guys any headaches in terms of difficult things to look at. So we are looking at our graph. G of x is equal to x4 minus 4x3 minus 8x squared minus 1. If we were to just factor out g of x, normally using synthetic division or long division, what does that accomplish for us? What information do we get when graphing just a regular polynomial function the way it is? We get our what? We get our x-intercepts, okay? We don't care about the x-intercepts. We want to figure out where my graph is going to be changing directions. So I need to take my derivative of g of x, which is 4x cubed minus 12x squared minus 16x. And now I need to find a common factor. So my common factor is going to be 4x. So I get x squared minus 3x minus 4. So remember, my slope of the tangent at my maxes and mins are going to be 0. So I got to set this guy equal to 0. Who can tell me what my trinomial x squared minus 3x minus 4 factors in? This is a simple trinomial, so hopefully it is easy for you guys to figure out the factored form. X minus 4x plus 1, thank you. So what are my 3 possible solutions in this factored out derivative? So what are my 3 solutions in this factored out derivative? Hey, Rabia. So we get, thank you, Ricardo and Ian and Priyanshu. We have x's is equal to 0, 4, and negative 1. So at 0, 4, and negative 1 is where the slope of our tangent is going to be 0. And it's also where we have a max or a min in our original function. So again, I can do my sign chart to figure out where I'm increasing and decreasing. And then that way I'll be able to figure out if I'm going to have a max, min at 0, 4, or negative 1. So I'm going to set up my sign charts. I do my sign charts differently. I'm not too sure if your teachers do them differently as well, but we'll see. So on my right-hand side, I'm going to write my factors 4x, x minus 4, and x plus 1, and my product as to what I get when I multiply all of these numbers together. So I need to pick a value between negative infinity and negative 1, so I'll pick negative 2. So when I sub in negative 2 for 4x, I get a negative. Negative 2 minus 4 is negative 6, so I get another negative, and I get another negative. So 3 negatives multiplied together, guys, gives us what? Negative times negative times negative gives us a negative. Okay, so that means between negative infinity and negative 1, my graph is going what? Up or down? Thank you, Ricardo. It's going down. Next one, a number between -1 and 0, -half. So you get negative, negative, positive. You get a result positive, which means that my graph is increasing. So next we have, let's say 1. So we get positive, negative, positive, which gives us a negative, which means my graph is going down again. And let's pick an x value of 5 because it's between 4 and infinity. I get positive, 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 which means my graph is going up. So we know that g of x increases between -1 and 0 in union with 4 and infinity. And g of x decreases on the intervals -1 or negative infinity to -1 in union with 0 and 4. So using this chart where it tells us where our graphs increase and decrease, can anyone figure out what my maximums will be at and where my minimum will be at? So who can tell me just based off my sign chart where my at what x value will my maxes or mins occur? Yep, perfect. So we have a minimum at -1 because we're coming down from -1. So I'm just going to roughly draw a graph. So we have -1. Let's see over here. Let's pick a random point. So from infinity to -1, we're coming down, and then at -1, we're going up, and then at 0, we're going to come back down again, and then at +4, we're going to create a minimum. So we have a maximum at 0 and a y value, a minimum at 4 and a y value, and a minimum of -1 and a y value. What that y value is, we got to plug into our original function and figure that out. So we have a max at x is equal to 0, and mins at x is equal to -1 and 4. Does everybody understand that whole thing right now? Does everybody understand this properly as of now? Okay. Is this easier than your test? All right. So now let's go into a rational equation function. So we have our function f of x is equal to 4x divided by x squared plus 1. So we have to use our quotient rule because we have a rational function. So I take f prime of x is equal to derivative of the first times the bottom minus the first times the derivative of the second, all divided by my denominator squared. So I'm going to factor this out. So I get -4x squared plus 4 when I expand and simplify, which means that my factor is -4. So I'm left with x squared minus 1 divided by x squared plus 1 all squared. So what can I do with my numerator? So what can I factor x squared minus 1 into? Difference of squares. So I get negative 4 times x plus 1 times x minus 1 all over x squared plus 1 all squared. So remember, my solutions are always in my numerator when it's a rational expression. And this x squared plus 1 all squared will always be positive. So my solutions are x is equal to negative 1 and x is equal to positive 1. So now I can make my sign chart. So I have negative infinity, negative 1, positive 1, infinity. So remember, negative 4 counts as a factor because that will always be negative. Then I get x plus 1, and then I get x minus 1, and then I get my product. So a number between negative infinity and negative 1, let's pick negative 2. So negative 4 will always be negative. This will be negative, and x minus 1 will be negative. And remember that my denominator will always be positive. So I technically have a negative number in my numerator, and dividing it by a positive number, negative divided by positive gives me a negative. So if I pick 0, I get negative, positive, negative, which means that I get a positive divided by a positive. So I get a positive as my result. And then I get a number bigger than 1, which let's say is 2. This is negative, positive, positive, and this is negative. So based off my sign chart and the factor derivative, therefore my f of x increases from negative 1 to 1, and f of x decreases from negative infinity to negative 1 in union with 1 to infinity. So as you can see, curve sketching back in advanced functions doesn't seem too difficult now that we do it. Or maybe even easier in derivatives. So hopefully this is so far so easy for you guys to understand right now. Okay. Let's move on to our last question. So we have y is equal to x times 4 minus x. So let's change this to x times 4 minus x to the 1 half. Okay, so now I have to do my power to a function, but it's easy because our derivative from the inside is just 1, or negative 1, sorry. So I'm going to get y prime is equal to 1 times 4 minus x to the 1 half plus 1 half times 4 minus x to the negative 1 half times negative 1 multiplied by x. And this gives me 4 minus x to the 1 half minus 1/2 times 4 minus x. So then I can take my x and multiply with my numerator, which means I get times -1/2. So now what I can factor out is I can factor out a 4 minus x to the 1/2. So I'm left with 4 minus x minus x over 2, or 1 over 2x. And then this simplifies to 4 minus x minus 1/2 x all over the square root of 4 minus x. And then I'm going to simplify my numerator, which gives me 4 minus 3 over 2x divided by 4 minus x. And to get rid of my fraction on the top, I'm just going to multiply both the top and the bottom by 2, which means I get 0 is equal to 8 minus 3x over 2 times the square root of 4 minus x. Remember, my roots only have to do with my numerator, so I'm going to focus on 0 is equal to 8 minus 3x. 3x is equal to 8, which means x is equal to 8 over 3. And remember, at x is equal to 4, it's undefined because of our square roots. So now we can determine what our sine graph or sine chart of my derivative is going to look like. So I have y prime here. I have 8 over 3 right here. And then I have 4, which becomes undefined after any number that comes past 4. Okay, because it turns the denominator into a negative square root, and we cannot have that. So I get negative and decreasing between 8 over 3 and 4, and increasing between 8 over 3 and negative infinity. So y increases between negative infinity and 8 over 3, and y decreases between 8 over 3 and 4. We have two more examples. Oh, this one will be easier because it's just basing it off the description of the words. So I want to graph or sketch a graph of the function that is differentiable and that satisfies the following conditions. So we have f prime is less than 0, so that means it's decreasing. When x is bigger than 4 and less than 0. So you have 4 over here, which means it's decreasing, which means there's probably a maximum over here. And when x is less than 0, it's also decreasing, which means I might have a minimum over here because it can be decreasing from left to right. I know f of 0 is 1. And x is bigger than 0, or increasing between 0 and 4. So I'm going to draw my sign chart, which means that this is 0 and this is 4. My slope of my tangent is going to be 0 at these places. So I'm going to have decreasing, increasing, decreasing. So if I were to sketch a graph, it would look like this. Again, my rate of change is negative when f prime of x is less than 0. It is increasing when my f prime of x is between 0 and 4, and it's back to decreasing when it's greater than 4. Because you can see my tangent moving downwards, moving upwards, then moving downwards again. Next problem we have is for the cubic function defined by f of x is equal to negative 2x cubed plus bx squared plus cx plus d. We want to find the values of b, c, and d such that f of x is decreasing to the point 0 and 2, and it increases to the point 2 and 10. So we know that at f of 1, so we're going to have multiple equations. We know that f of 1 is equal to, f at 0 is equal to 2. So now I can use my regular function, negative 2x cubed plus bx squared plus cx plus d, to find out what my d value is going to be. So I get 2 is equal to negative 2 times 0 cubed plus b times 0 squared plus c times 0 plus d. So all of these become 0, which means that d is equal to 2. Perfect. We have my d value. Now my second part that I know based off the graph, I know that f at 2 is equal to 10. So now I can try to come up with an expression that helps me find b and c. So I get 10 is equal to negative 2 times 2 cubed plus b times 2 squared plus c times 2 plus 2, because that is our d. So I get 10 is equal to negative 16 plus 4b plus 2c plus 2. I'm going to move negative 16 over. So I get 26 and then minus 2, which is 24, is equal to 4b plus 2c. I can divide both sides by 2, so I can get rid of a common factor, which leaves me with 12 is equal to 2b plus c. So I know based off of my description of my graph, so I know my f prime of x has to be 0 at these points because it's either increasing or decreasing. So based off the information, I know that it's decreasing from 0 to 2 at the point 0, 2. And it increases to the point 2 and 10, and then continues to decrease after that. Which means I'm going to be decreasing and then increasing. So 0 is going to be a turning point, and x is equal to 2 is also going to be a turning point. So because it's going to either be a max or min in between those two x values, I need to find my f prime of 0 is equal to 0. Okay, so I need to find f prime of x is equal to 0. Sorry. So now I'm going to take my derivative of my original equation is equal to, so the derivative of negative 2x cubed plus bx squared plus cx is negative 6x squared plus 2bx plus c. And because we can sub in f prime at 0 to check one of the roots, yeah, that's one of the turning points, f prime at 0 is equal to 6 times 0 squared plus 2b times 0 plus c. So that means 0 is equal to c. So I can figure out my b value by subbing into number 2. So I get 12 is equal to 2b plus 0, and b is equal to 6. Which means that my b value is 6, my c value is 0, and my d is 2. Okay, and then we're going to do our last question, and that's going to be it for this lesson. So each of the following graphs represent the derivative function f prime of x of a function f of x. Determine the intervals of increase and decrease of f of x and the x coordinate for all local extrema of f of x. Then sketch f of x, assuming f at 0 is equal to 0. Okay. So when we have our derivative graph, the roots, this is the general rule, the roots of my derivative graph are my turning points in the original function f of x. So as you can see, we have a root of negative 1 and 0, and 2 and 0 over here. So that means at negative 1 and 2 in my original function, those were considered to be turning points. So based off of my derivative function, I know that my roots are negative 1 and 2. And based off of my graph, I know that my rate of change in my derivative function is below 0 between negative 1 and 2. And it is above 0 after negative 1 and after 2. So that means f of x, or my original function, is increasing between negative infinity and negative 1, and 2 and infinity, and it is decreasing between negative 1 and 2. So now what my graph is going to look like is it says assume f of 0 is equal to 0. So I know that I'm going to have a maximum at a negative 1 and a specific y value. So I'm just going to make one up. Because again, my graph is increasing from negative infinity to 1. And I'm going to have a minimum at 2 and a random y value, because I know that my graph is increasing from 2 to infinity and is decreasing from -1 to -2. So this would be my cubic function. This would be a rough sketch. So my derivative function was a quadratic, which means that my normal function is going to be a cubic function. Okay, so let's do the next one. So here we have a cubic function as our derivative function. So again, we're going to be looking at f prime of x. So we have our roots. We have -2 and 0. So when my x's are less than -2, as you can see, my y values are approaching 0, which means that I am going to be getting a negative y value at all times. When x is between -2 and 0, I'm going to be getting positive y values the whole time in my derivative graph. And when x is greater than 0, again, I'm going to be getting positive values in my derivative function. However, what this means for my parent function or my normal function f of x, it talks about my intervals of increase and decrease. So my f of x is increasing between 2 and -2 and 0, and 0 and infinity, and it is decreasing from -infinity to -2. So again, the zeros in my derivative function are going to be my turning points in my original function. So again, we have to assume that I pass through 0, 0. So again, I have a minimum at -2 and a specific y value. Because my function is decreasing from -infinity to -2. And then from -2 to 0, it continues going up. And then because my derivative is a cubic, I need my normal function to be a quartic function or of degree of 4. So my graph is going to look like this. And there's going to be a bend at x is equal to 0 because I have one root at, in this case, -4, and a triple root at 0, which means that my exponent is going to be x cubed times x plus 4. We can only assume that, and that's why there is a bend at x is equal to 0.